What's happening, dogs? Mr. Allen here working with some chords of circles in this video, and we've got a lot of given information in this one. I've got circle O, AB is perpendicular to OF, DC is perpendicular to OE. I got AB is 3x plus 2. I'll just go ahead and write that down right now. We got 3x plus 2. And then DE is x plus 4. So just this guy's x plus 4. OF is 24 and OE is 24. So OF, 24 and 24. Okay. And then I've got the perpendicularity going on, right? So AB and OF are perpendicular. That would give me a right angle. So I'll mark it, and the same goes down here. So what the heck do we do with this type of information? Well, there's a wonderful property of circles. Circles have tons of properties, man. It always seems like you don't have enough information, but everything just kind of falls into place with circles. So if I have chords that are equidistant to the center, okay, and distance is measured perpendicularly to that chord. So since this guy right here is perpendicular to this chord, and this guy right here is perpendicular to that chord, right? These two are equidistant from the center, and that means that the chords are congruent. And the chords are bisected because if a radius is perpendicular to a chord, it bisects that chord. You might be like, wait, this isn't a radius. It doesn't go all the way to the edge. But you know what? I could extend this out, and it could hit the edge. Same goes over here. So it could be a radius. It's drawn from the center to the edge of the circle. If it's perpendicular to the chord, it bisects the chord. If they're equidistant, these chords are congruent. So let's put all that information into one thing. Well, let's see here. I have DE. Wouldn't this also then be x plus 4? Because we said that it is bisected. So therefore, these chords are congruent. These chords are congruent. And I'm using the same congruent marks here because both chords are congruent. So their bisected parts would have to be congruent as well. Ooh. All right. So how about this? I can do x plus 4 plus x plus 4. That's going to equal to 3x plus 2, right? That works. I could also cut this guy in half, set it equal to the x plus 4, but then I'm dealing with a fraction with the 3x. If these were even numbers, I would do that, but it's not, so I'm just going to add those two together. So let's set that up. We got x plus 4 plus x plus 4 equals the 3x plus 2. Now I can solve this. So I'm going to go ahead and combine like terms on the left-hand side here. I've got, 2x plus 8 equals 3x plus 2. And I'll solve. So I'm going to subtract 2x on both sides. That cancels that out. I'm going to subtract 2 on both sides. So now I have 6 equals x. Boom. Didn't even have to divide. All right, so that's great. Should I box this and say, hey, I'm done with the problem? No. No. We got to read the whole thing. Find the area and circumference of circle O. So I've got the first part done. I have my x value. But there's a lot more to be done in this problem. So if I were to bust out, let's see here, this blue marker, we'll continue with this one for the next part. X equals 6. How do I use that? Well, I could plug that in and find some lengths, right? That would make this guy, let's see here, 6 plus 4, that would give me 10 right here. Same goes with that one. Over here, I would get, 20, because it would be 18 plus 2, and that makes sense. They should be congruent. I've got this 24. I wonder if that plays a role other than telling me that these chords were congruent because they were equidistant to the center. Well, oftentimes, in geometry, not all the time, but a lot of times, we try to draw right triangles within a figure to help us solve for some missing lengths that'll help us solve the entire problem. You'll do it in circles. You'll do it in three-dimensional figures like pyramids, cones, all that good stuff, right? So drawing right triangles will help you solve problems. Even out in the wild, if you're building stuff and whatnot, right triangles help you out. So let's try to get a right triangle going here, which means I'm going to probably need another side because I don't see any triangles. Now, I could draw, let's think actually one more thing. What do I need to find area and circumference? I need a radius, right? And I can draw a radius in an infinite number of ways here. I can draw it all over the place. But there's 4 locations that would be very helpful. Either here, 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 or here. Why? Because that would create a right triangle. Since I'm doing quite a bit of math over in this one already, I'll just go ahead and line this up. See here. Scribe my little hypotenuse action right there. And now I have a triangle where it's 10 for this side, 24 for this side. What is this side going to be? I'll call this C because it is my hypotenuse. All right. So we can set up some Pythag here. 10 squared plus 24 squared equals c squared. All right, so this is my triangle right here. We got a side length of 10, side length of 24. I'm trying to find my hypotenuse, which is going to be my c squared in this case. Now, we could work all through this, or you may notice that this is a 5, 12, 13 triangle cut in half. All right, not everybody sees that, but this is 5 times 2 is 10, 12 times 2 is 24. So it's a 5, 12, 13, or a 10, 24, 26 triangle. And now I have my radius of 26. So we could also even just say like r equals 26 in this case. Cool. Awesome. And if you needed to, you could have done 10 squared plus 24 squared, throw it in your calculator, square root it, it'll give you 26. All right. So now I can find my area and my circumference. Let's do it. I'll use orange. So area, that is pi r squared. So let's throw our radius in there. Oh boy. So times 26 squared. What is 26 squared? 676. Let me grab my trusty calculator here. I think that might be right. Let's see here. 26. Hold on, it's validating. Validating the OS right now. That happens from time to time. Yes, 676. All right. So we get 676 pi units squared. Lovely. Now, usually in math, like in mathy math, not like application land, we often keep it in terms of pi just because it looks neater. So I'm going to go ahead and say this is the area of the circle. Final answer on that one. And now let's get that circumference as well. I'm going to go with a, purple. How about? Okay. So for circumference, that is 2 pi r, or pi times diameter. Either way is cool. So this one is 2 pi times 26. So it's going to be what? 52? 52 pi units. If I gave you units, you could go ahead and tell me what those units were, but I did not give you guys any units in this one, more of like an algebra style problem. But there you go, guys. Beautiful. So, chords of circles. As long as you have one piece, okay, that they are equidistant to the center, or that they have been bisected, or that they are perpendicular, the radius is perpendicular to it, you get everything else, okay? So if I've got two chords that are equidistant to the center, now I know that they're bisected, I know that it's perpendicular, all that good stuff, right? So a lot of stuff kind of falls into place for circles. I hope that helps you guys. Have a wonderful, wonderful day. Thanks for watching, and stay awesome.